Here we want to find the sample size needed to estimate the percentage of adults who can wiggle their ears. Use a margin of error of 5 percentage points and use a confidence level of 95% and complete parts A and B below. For part A, it says assume that the point estimate and the complement of the point estimate are unknown. So if it's unknown, then we need to use a certain formula. And then we're going to round up to the nearest integer. So here's the formula that we're going to use for the sample size. Now we need to find information. So we already know that the margin of error is considered 5 percentage points. And so 5 percentage points in this case is equivalent to the decimal of 0.05. Okay? And then the other thing that we need to do is we need to find what is the Z critical value. Okay, so remember that in order for us to find that critical value, what we need to do is the following. Okay, we want to find alpha. Okay, and so if we want to find alpha, it's saying that the confidence level is 95%. So remember that's going to equal 1 minus 95%. Which is the same thing as 1 minus 0.95, which gives us 0.05. Now we're going to take that alpha and then divide it by 2. So we're going to take 0.05, divide that by 2, and that gives us 0.025. Now remember what that means is that we would have the bell curve, okay, and that the area to the right of that critical value that we're looking for represents 0.025. So what we want to do is now find the critical value with that area to the right. So the critical value is going to be Z greater than or equal to whatever that critical value is going to have an area of 0.0250. Now we can do that using StatCrunch. So let's go ahead and open that up. Okay, so we're going to go to Stat, Calculators, and then scroll down to Normal. We want to make sure the area is to the right, so we're going to select the inequality to point to the right. Okay, we want to find this critical Z value, so we're going to put in the area of 0.0250, and therefore we're going to get 1.96 rounded to 2 decimal places. So therefore that's going to represent the critical value. Now that we have that information, now we can plug it into the formula. So now this is going to equal the critical value, which is 1.96. We're going to square that and then multiply it by 0.25. And then we're going to divide that by the margin of error squared. Well, the margin of error is 0.05, and then we're going to square that. So let's go ahead and do this in our calculator. So what we're going to do is we got parentheses 1.96, close the parentheses, we're going to square that, and then we're going to multiply that by 0.25. Enter. So that's what we have in the numerator. Now I'm going to say divide by, in parentheses, 0.05, and we're squaring that, and that gives us 384.16. So 384.16. Now recall here that it says that we need to round up to the nearest integer. So that means we need to round up because we're dealing with a sample size. So therefore this is going to give us 385. So let's put in the answer 385, and there is our result. Now it says assume that 22% of adults can wiggle their ears. Well, now that we're given a point estimate, we're going to use a different formula. Okay, and so that formula is the following. Okay, we have n, which is equal to the critical value squared times the point estimate times the complement of the point estimate over the margin of error. Well, we already found from the first part that the margin of error is 0.05. We also know that the critical value is 1.96. In the problem, they're telling us that assume that 22% of the adults can wiggle their ears. So that means that the point estimate is equal to 22%. As a decimal, it's 0.22. And then the complement of that is going to be 1 minus 0.22. And that's equal to 0.78. Now we're going to use that information and then plug it into our formula to find the sample size. So n is going to equal the critical value of 1.96 squared times the point estimate, which is 0.22, times the complement of the point estimate, which is 0.78. And then we're going to divide that by the margin of error, which is 0.05 squared. Okay, so let's go ahead and do that in our calculator. So we have parentheses 1.96, square that, times the point estimate of 0.22, and then times the complement of the point estimate, which is 0.78. Okay, if we enter, then that's what we have in the numerator. And now we're going to divide that by the margin of error squared. So it's 0.05. And then square that, and that gives us 263.6874240. And now recall that we want to round up for the sample size, so this is going to be 264. So here we're going to get 264, and there is our result.